Now that we've gotten comfortable with the idea of a derivative, we're ready to find what are called the antiderivatives. Before we get too far into it, I want to talk about what we call the constant problem. I want to consider three different functions. Let's say f of x equals x squared plus 3. G of x equals x squared minus 7. And we can even do kind of a crazy one. H of x is equal to x squared plus pi divided by the square root of 2. All three of these functions are almost identical except for the constant that's added or subtracted to the end. And what's interesting about all three of these is when we take the derivative of the first one, we get 2x because the derivative of a constant is 0. When we take the derivative of the second one, we get 2x because the derivative of the constant is 0. And when we take the derivative of the third one, we get 2x because the derivative of the constant is 0, which means all three of these have the same derivative. Our goal in this chapter is to be working backwards from the derivative back to what the function was before we took the derivative, hence the antiderivative. But when we are working backwards, we don't know the constant. In other words, if I had one of these three functions on the right, we don't know which one of these, the blue, green, or gray one, gave us the 2x as an answer. We don't know the constant. And so what we will have to write on our indefinite integrals, our antiderivatives, plus c to represent some unknown constant. I used that word integral in my previous sentence. What did I mean by the integral? When I say the integral, we're going to use this notation of this little squiggly thing. That's the integral of some function dx. The dx tells us with respect to what we are taking the derivative of. What this notation means is we are asking whose derivative is f of x. So let's look at a bunch of examples that we might have seen before and we could probably figure out. First off, let's say we want to take the integral of maybe e to the x dx. Whose derivative is e to the x? Well, we remember that e to the x had a derivative of e to the x, but now we're going to have to add that plus c because there might have been a constant added to the end whose derivative was 0. Let's see if we can figure out another one. Let's look at the antiderivative or the integral of 1 over x dx. Who had a derivative of 1 over x? Well, we remember the natural log had a derivative of 1 over x. Now, to make sure this is defined, because the natural log is undefined for negatives, we're going to have to put it in absolute values. There's a minor change there just to make sure we take care of the domain issue. But the antiderivative of 1 over x is natural log of x because the derivative of natural log is 1 over x. How about this one? Let's find the antiderivative of some constant, I'll call it k, dx. Who had a constant derivative? Well, if we took some constant times x, its derivative would have just been the constant. Of course, we're going to add the extra constant of the plus c to account for that unknown constant. How about this one? What's the antiderivative of x to the n dx, the power rule that we love so much? Well, when we're taking the derivative, we bring the exponent out front, and then we subtract 1 from the exponent. The antiderivative, we're going to do the opposite. Instead of subtracting 1 from the exponent, we're going to add 1 to the exponent. And then instead of multiplying, we're going to divide by that new exponent. And of course, plus c. Now, there's a few properties that will also help us with integrals. Similar to the derivative properties, if I want the integral or the antiderivative of a constant times f of x dx, that constant can be just pulled out front, and then we can just integrate the function with respect to x. So just like we could put a constant in and out of a derivative, we can put a constant in and out of an antiderivative. And if we wanted to do the antiderivative or the integral of two functions added together, dx, we could, just like we took derivatives of both terms, we can take the antiderivative of the f of x dx and add the antiderivative of the g of x dx. These 6 properties of integrals will help us solve lots of different types of integral problems, and that is the topic of our next video.